Hello, and welcome back to physics. We've been discussing all semester this idea of interactions and how interactions cause motion, right? We saw how forces give us accelerations. We've seen how work done on an object causes an increase in kinetic energy. And we've seen how impulses cause momentum to change. And throughout all of these discussions, yes, we've been detailed about the idea of interactions causing motion, but we've skipped one crucial part of the conversation. And that crucial part of the conversation is what exactly is feeling these interactions. Because depending on what's feeling the interaction, we get vastly different behaviors. And it's important to understand how those behaviors shift depending on the objects we're looking at that are interacting. And today we're going to really be diving into this idea that different types of objects exist in this world and that we fundamentally want to understand how they behave under interactions. So, where does this get us? This takes us to an important discussion of matter and specifically the different phases of matter because an object can exist in different forms depending on temperature, pressure, all these other things we'll talk about next semester. But an object can exist in different form, and depending on what form it's taking, the interactions will have different implications to it. So we want to understand first, what are the different forms matter can take on, the different phases of matter, and then we want to discuss a material property, the material property of density, because density tells us a lot about how interactions will occur as well. So we want to understand density. Density also helps us understand how to identify different materials. So it's a very useful quantity to understand and to be able to use. From this idea of density, we can describe two types of materials. We can describe a compressible material and an incompressible material. And basically, that means can you take an object and squeeze it into a smaller form or not? We'll get more specific to that definition a little bit later, but these are our three goals for the video. Diving into the first one, we are going to focus on three forms of matter. There exists more, to be sure, but we'll focus on three. And we're not even really worried at this point how materials go from one form to another. We're just saying, hey, these three types of matter exist. Now, there exists type of matter solid. We're familiar with this, probably this idea of solid, liquids, and gases, but bear with me. There exists this idea of a solid. What is a solid? Well, solid is very well defined as being containing a specific shape and a specific volume, right? The more physicsy way we would describe it is that it resists shearing forces. What is a shearing force? Well, if you take this collection of 9 molecules here and you apply on the top right a force to the right, and at the bottom left you apply a force to the left, try and pull it apart, this is what we would call shearing an object. And in the case of solids, well, it resists this shearing force. So if we look at this top right molecule right here, that top right molecule will resist and try and be pulled back to the left. Solids will resist this shearing force. When it comes to liquids, however, liquids are interesting because liquids do not resist that shearing force. If you take this molecule up on the top right and pull it to the right, the one on the bottom left, pull it to the left, those molecules will just move freely. Same with gases. Gases on the far right. If you take the top right molecule and the bottom left molecule and you try and move them, those molecules will just move. They do not resist this shearing force. So you get this difference in behavior between solids as well as liquids and gas, in that some of these resist shearing forces, some of them do not. The types of materials that do not resist shearing forces are what we term as fluids. They can flow, and the resisting of shearing forces is important for an object to be able to flow. So we get this idea of fluids being liquids or gases, and physics defines that as resisting this shearing type force. So liquids and gases, they both are fluids, and we haven't talked about fluids. Everything we've done up until this point has been talking about solid objects, objects that will resist the shearing forces. That means all of these atoms essentially will move together as one. You apply a force to a solid, all of the atoms move together. Why is that? That's because with all of these atoms, they are bound together with these forces. You can kind of picture the forces between atoms as springs. And they're all attached to each other. So when you try and move the collective, when you move one atom, you move the collective of atoms. Fluids are different. Fluids are different because you can freely move one atom in some direction without really affecting all of the other atoms. So our fluids are not the same as our solids, and really the reason why we're having this discussion is because now we want to shift our frame of reference to how do solids interact with solids to how do fluids behave under interaction. So really we're focusing on these two ideas of fluids, liquids and gases. But before we really dive into fluids, right, we understand solid, liquids, and gases exist. Liquids and gases are a fluid. But before we really get into that, we want to identify the idea, the concept of density. And this is going to be important when differentiating different types of fluids. So again, bear with me, this does have importance. When we take a look at any object, an object can be defined by its physical characteristics. What physical characteristics exist? Well, you look at these two objects on this picture, a wooden block and a little chunk of metal, and you can say they have certain physical characteristics. You could label off their color, their smell, their taste. All sorts of different things can define these objects as what they are. But two of the most important to physics are going to be their size. Back to Alright, so size and mass tell us about the physical characteristics of an object, right? And these are two ways for us to describe, any object has some size or some mass. But how do we define the size? How do we define the bigness of an object? Well, typically we just use the volume measurement. In this case, for these two objects, we'll do the height, the length, and the width multiplied together. And that would tell us the volume, right? And then we think about mass. What is mass? Well, essentially what mass is a count up of the number of molecules that are present. We go back to this previous slide. We say, what is the mass of an object? Well, the mass of an object is going to be related exactly to how many of these molecules are present. Now, it's unrealistic for us to actually count up all of the atoms in an object. So instead, what we do is we compare it on some sort of scale, right? And typically for mass, we have this idea of a kilogram being our measurement. But again, it just goes back to how many molecules are present. So what is density? Density, which we use the Greek symbol rho to represent. Density is a description of essentially how many or how tightly packed our molecules are, how close together are our molecules or our atoms. How do we define that? Well, we can define density by taking the mass of an object, how many molecules are present, and dividing it by the size of an object, dividing it by the volume. So we get this quantity of density, which is mass over volume. What's interesting is that this value of density, it's unique to any given type of material. So for example, you take a block of copper, like what you see in this picture, and any block of copper will have the same density related to it. However, something like wood has a different density than copper, but that chunk of wood has a similar density to every other chunk of wood. So it's dependent on the material that is there, although it does not change for that material. So because of that, we call it a material property. Density is our material property. It tells us about what object is here. And what's interesting is from this material property of density, or what's more interesting, you get different behavior, such as will an object float? That can be predicted only from the object's density, and we'll figure out exactly how to do that in just a few short lectures. But for right now, we identified this idea of density. How does this relate to fluids? Well, for fluids, what we can look at is any region of fluid, right? We take a container of liquid here and we outline this region 1, right? And we can figure out the volume of this region 1. We can imagine taking this region of small, this little cube of water out and putting it on a scale. We can figure out its mass over volume. We can figure out the density of region 1. You can do that for a different region as well, or a third region even. And what you'll find is that for any, we call them uniformly dense object, for any uniformly dense object, you would get that the density, no matter what region you look at, is going to be the same. Although, in fairness, there is slight changes as you get further down. There are slight changes because as you get down, pressure increases. We'll talk more about pressure. And you get small changes in density. But for the most part, we get a constant density here. A constant density for our liquids. But that's true for liquids. Gases are different. Because with our gases, right, we could take this balloon, right, and it has some volume, and we could find the mass of that balloon, right? But what we can also do is we can compress the balloon. We can make the balloon smaller. And what does that do? Well, it puts a lot of strain on the system. The balloon will fight back, but you can squeeze it down. And you can squeeze it down, and as you squeeze it down, the mass stays the same. We're not losing any molecules, but the volume decreases. So you get some sort of a changing density here. And for any fluid, we can define whether or not they change density or whether we're able to change the density as this idea of compressibility. So for liquids, generally we say liquids cannot really be compressed. So we say they're incompressible. Whereas gases can be pretty easily compressed, so we get compressible fluids. So whether an object is, or when we look at an object, we first want to be able to define what is its state of matter. Is it a solid, a liquid, a gas? We also want to be able to figure out its density, because if it has a changing density, then it is said to be compressible. If it does not have a changing density, then we say it's incompressible. And for most of the foreseeable future, we are going to be primarily dealing with this incompressible fluid. That's what we're looking at now. Why do we do that? Well, because most liquids are incompressible, and we want to understand how do liquids behave. Next semester in Physics 36, we'll talk more about compressible fluids, but for right now, we're going to deal with incompressible. Okay. In the next video, we're going to talk more about this idea of fluids and specifically this idea of pressure. I mentioned it a couple of times in this video, but really here we're just looking at phases of matter and whether or not something is or is not compressible. Thank you guys so much for listening, and I'll see you in the next video.